Hi guys, well, welcome back. We've decided to do a bit of turning, and would you believe it? If you're like me, and I hope you are, that the first lathe, any lathe, wood steel I ever even switched on was well, it was this one. So I knew nothing, and I got it on Friday and picked it up. It's from Ardendorf. It's a McCaffrey BL180. I didn't know what anything is. I sort of had an idea, that moves it and that moves it and that, but I didn't know the rest. So I'm quite lucky with this model because it comes with the auto traveler over here. That's a thread over here that moves this up and down automatically, and that's very, very important. So it was 12 grand, and that's for the basic machine. And I never ever used these. And I thought, well, I'm going to learn, I guess. And then I looked on YouTube, and there really wasn't a lot. Um, they kind of explain, but they don't really, and I couldn't find much on this particular machine. And what is needed, fortunately, the guy was very helpful, and he did. I did buy some stuff, and a lot of it is, yep, okay. And then I bought other stuff. It's useful, and but what is important? So this video is about a steel lathe and this particular model, the BL180, and how to get started. Because like some washing machines you buy, they got those plugs in. You can't even switch it on until they. I didn't even know. Like, can I switch it on? It comes with a whole bag of gears. What are those for? I don't know anything whatsoever. So, but I thought, well, I'm going to learn. So, what this video is about is to just get you started. I'm not going to get into any fancy tools or anything because I don't know anything about that. I'm not going to get you into fancy terminology because I don't know anything about that except for deflection. That one I got. I've got that. We'll get to that. Um, so this video is a little bit long, but I urge you, if you are looking at buying a steel lathe, to watch the whole video through. If it has helped you, please leave a comment, please like, please subscribe. Obviously, we need the money because, well, it costs a lot of money, and this is the tools are that's where the trouble comes in, really. So I'm going to try and just go through some things initially, what it comes with, and what I got extra, and what is really useful, and that's about it. So before we go any further, it comes out of the box and you get it down. Now, it makes sense, obviously, to make it as level as possible. Some of them you can actually bolt down. I don't think you cannot bolt these things down. But I mean, I can even get a piece of granite or something and level the granite, because if your whole body is, this slight deflection or something can affect your accuracy. But I think if you're like me, geez, you just want to be able to use it. You're not really that worried about accuracy just yet. Um, but get it as level as possible, obviously on a sturdy workbench, that it doesn't go all over the place. Because remember, this thing spins up to 2,500 RPM. You got a piece of steel in there, that thing can go flying. It's mental. It can go mental. So just be very aware that this is not a toy. Um, it's a lathe. It's a steel lathe. So what are the extra? What do you get with it? First off, it comes as it is here, except for the light. And then it comes with some bits that go in the end here to sort of hold your stuff. And it comes with three of those. One of them is like super large and actually turns with your workpiece. Um, and then it comes with two of these smaller ones. So that's as far as the tailstock is concerned. It comes with that. What I would suggest you do is get yourself an extra arbor with a chuck on. This is the 1 to 13 millimeter keyless chuck, and some of these center drills. I think they're not very expensive center drill set. 1 to 4 millimeters, and I'm going to show you what that does in a minute. But also you can put a drill on and you can drill into your workpiece and do all sorts, like your inner boring and everything. So that is a definite worthwhile extra to buy. When you do buy it, this arbor comes with a tail piece on the end. That's not necessary. That's for bigger drill presses, and those I have used. So what you do, leave it on, and then you put that in a vise, put it in there, and then just give it a 1-2 taps with a hammer, and it'll go in. That's not really going to come out, and then grind that off. And that, because that will affect it over here. So rather just grind it off. You don't need that on this particular lathe. That's as far as the tail stock is concerned. For the center carriage, or whatever, I'm going to call it the center carriage. Excuse me, you're going to need some cutting tools, right? That's a good start. You're going to need, because a lathe just turns steel, and this is the carbide tip tools that I got. It's just one set. Just get the set, comes with these inserts. You can buy the inserts separately, and then when they chip or get blunt, you can just turn them around and reuse the other side on them. So this is a basic set, and that is great. I've used practically every single one of them on one workpiece. Your lathe itself is going to come with a chuck key. The chuck key's got a spring, so it doesn't remain in there. Don't take the spring off, because it's going to be easy to leave that in there, and then when you switch a lathe on, that's going to go flying across the room. And then it's going to come with a stack of Allen keys. They all have a use, so you will be needing those. Just on the Allen keys, remember, Allen key is a very, very, very specific design. It is designed to allow you to tighten something so tight and not any further. So don't be getting a ratchet or something to try and make things quicker. Stick to the Allen key, because you don't need a lot of torque on these. There's a lot of grip, and it is designed to not allow you to put too much torque on something. So one never wants to overdo it with an Allen key. And I think that pretty much covers that essentials, really. And definitely, get some cutting fluid. You're going to need it. I just got 3, super cheap. They're like $50, and for 500 mils. And yeah, that is something you're going to need. I also got a little bottle while I'm busy, I can get it in there, because that's quite big to get in there. Then you will need a veneer. You will need ChatGPT, and you will need a lot of patience. And that we're going to get to when we start turning something, which will be this piece of aluminium. So onto the main unit itself. It is currently unplugged. As your machine comes out of the box, it's going to be covered in grease or whatever it is that they coat it in to ship it in from China, who are international manufacturers. So you just want to clean that off, and then get some Q20 or something to keep everything lubricated. All of these, everything lubricated. I just use some multi-purpose spray or Q20 or something. Keep it lubricated. And another nice addition, which I found a little home for in the back here, is one of these magnetic. It is a micrometer holder. So this is very nice to have. We are going to give it a run, and we're going to see what it can do. And it's got a magnetic base, so I pop that in here, so it's well out of the way of the chuck and everything. I switch it on, and it's stuck there. And then you've just got to be careful, because that can get in the way of the chuck key. Then the light. This light I got off Take-A-Lot, would you believe it? And it's like it was made for this. It's perfect. It just plugs into a little USB power, and that folds out, and you can switch it on. Then you're going to need some light. So, you can hang LEDs off the roof, but, this is super cheap off Take-A-Lot, and it's like, I don't know. It was made for this thing. I mean, that's amazing. So that light you're going to need. And then we get onto the main drive unit itself. I think I'm going to turn this and just zoom in a little. There's not a lot of controls, but okay. This is your safety switch. It is unplugged at the moment. So before you can go anywhere, you have to slide that up. So if you ever have an emergency, it's right here. You switch it off. It stops. You've got your forward and reverse. Leave it in forward for now, because that is going to that's basically the main direction. That's coming this way. That's the main direction you're going to be turning in. The turning tools are designed for that direction, as you can see, and because they're cutting away here, and that's how you do it. I've actually never tried to switch it off there, but that makes sense to me. And then around the back here are going to be two levers. Let me just take this off and show you what's going on here. Right, so around the back, one is for, I've just switched it off, high and low gear, and that one is for forward and reverse. The forward and reverse is for this over here, your auto feeder, and then the high and low gear is for your motor. There's a reason why they're at the back, and that reason is because when you are changing gears on the machine in any direction to a high and low or forward and reverse on the feeder, the gearbox sits inside here. You do not do it with the machine running. You will strip the gears. So they put it at the back, so you like, okay, we have to switch off. It's kind of like a mental thing, and that's why they are there. Let's put a light back on because I like it on. There you go. And then this is your off, and then your speed control. So it says here in low gear, when it's on max, it's a 1,150 RPM. And when it's in high gear, which is over here, 2,500 RPM. And always just get into a habit of switching that off. Now, when you change this lever over, what I like to do is just, okay, I don't know if you can see, manually rotate this with your hand. So don't just try and do that because the gears aren't meshing. Make sure they mesh properly and it's all the way across. Because you'll feel as you start turning it, it sort of clunks into gear like an old car. And then your high and low, not so much. But you've got to pull out this thing at the back and then lift it up. You'll see there's two little indentations. We're going to show you in a minute what that does. So that's as far as this assembly goes. You're going to get a bag of gears. Don't be confused too much by them. These are for cutting different threads, and there's a whole threading chart over here. The gears affect the speed of this, the auto feeder. That's the only thing they affect. Let's just zoom out again. So your gears are only affecting the auto feeder, this bar here. They're not affecting the motor speed or anything. And your high and low gear, and that affects the motor speed, and that affects the direction. So once you've cleaned everything out the way, everything's sorted, nice, ready to go, you may now plug your machine in. And you're going to see a little light illuminate over here. I don't know why it isn't. Perhaps I'm plugged into the wrong, I plugged in the wrong thing. Always helps if you plug in the right thing. Is that the lathe? I'm trying to plug in here. Okay, let's just pause that and see what the issue is. And we are plugged in. I found out what the issue is. That emergency switch was not on. So if that is off and you plug it in, let's wait for that to go. It won't, it just doesn't want to go. I think it was out, eh? Ah, there it went. So we've kept it off. Now it will not switch on again because that is on. So try as you may, isn't going to happen. So leave that off and switch it on, and then you can start turning it. Now they do recommend that you run it for 2 minutes. I ran it for like 2-3 minutes in one direction and in the other direction. So I changed gears. I did forward and then I ran reverse. See, now it's going that way. This is turning down. I switched it off. Ah, now I've just discovered something myself. Doesn't like that. There you go. That's quite important, obviously, because we're going to get to that. So, your center carriage. Over here, let's zoom into that and get it into focus. I think that's a little bit too much zoom. So this will move your entire tool unit forward. That will move it backwards. This will make some minor changes. You'll see there's markings on it. So every sort of line I move it, it moves 0.025 millimeters. So to get this thing to move 0.01 millimeters that way, you've got to go through 1, 2, 3, 4. So you can get a relatively bloody good accuracy on this machine. So what you want to do is install your tools. Now, if you'll look at this, let's move it across. Make sure you're off. This is your tool post. And you do not want your tool sticking out too far. So I'm going to show you here. Where is it? Where did you go? There it is. Can you see how far it's sticking out? The further out it comes out, the more deflection you're going to get. You can put it at an angle. You can also turn this whole post. And then but then it's 3 screws. Now what I've done here, this you have to undo quite a bit, is I've put 2 different tools on. So that will allow you to just turn this and change without having to change tools a whole lot. Because you can spend quite some time with an Allen key on this and just swapping over your tools. So it's this one. We want to make sure it's down and zoom out a bit. Let's go down here. Now watch this. Your auto feeder is disengaged. Your tool is tight. There is an old piece of stainless in there. And you can move it by hand. Okay, but when you switch it on, let's put it on. Nothing is happening. Nothing is happening until you engage, and this you can and should do while it's in motion. Your auto feeder is turning, but once you've engaged it, you're going to see the handle turning. You can see it turning. So it's actually auto feeding across to the right. And then I switch the machine off. I come to the back and I lift that up, and then I switch it back on. Now it's going to the left, and the faster it goes, the more it's going to auto feed. To disengage the auto feed, just lift that, and it's that simple, right? So we want it off, we want that on. So this is kind of like your little auto feeder dance. So auto feeder is very important. I didn't think it was, and I didn't really even look at other machines. So I can't say other machines I've looked at will have an auto feeder. But to get a really smooth, even surface, it's better that this thing does it itself, because when you're trying to by hand this and that, you're basically scraping, cutting away at a piece of steel. So if you're moving too fast, you're just going to get a whole lot of lines, and your workpiece is going to come out looking terrible. I mean, you can see this, you can't really see the lines on this, but that's probably because I haven't turned that piece yet. And so I'm trying to see if I can find an example. One I have turned, and it doesn't come out great. So you have to have the right tool, the right RPMs, and the right speed here. The auto feeder speed, remember, for threading can be changed with the gears. It can also, the gears, your additional bag of gears that comes with it, can, that's all of these little guys in here. It also comes with a set of extra chuck jaws, whatever they're called. And those gears can only affect the auto feeder. So if you need to kind of go faster, do it with those gears. There is a chart. The jaws on the chuck, that's this over here. If you remove them, they must go back in the same position they came. So that's 1, 2, and 3. They have to go back. So if you flip them around, that one must go back in there. Not that slot, not the other slot. And be careful they don't drop out, because they'll get damaged. So what I'm going to do is I'm going to take out, I think we've covered everything. I mean, we've got the done the auto feeder. We haven't covered the RPMs that we're going to get to, and that's a result of deflection. So that's a piece of terminology we're going to be focusing on, because yeah, I'm trying to do really small stuff. This is how I got to this. The stuff I want to do is really small and finicky. I don't have a drawing and everything. And I just cannot go all the way to an engineering shop, give them the specs. This is what I need. They make it, come back, test it. Doesn't work that way, go back. They set their machine up, come back, test it. You're going to see when you're setting up your machine, it takes some time to get your machine set up nicely. You're already running. You got your motor running, your feeder running, everything. You understand the gears. That is your forward and reverse on your auto feeder, and your high-low, which affect your RPMs. You know your motor direction, and you know how this can work. There you see, you can put 2 tools in, and we will get to that. There's a couple of tips and tricks. Don't make a mistake on that. So you're already up and running, but to really get your machine dialed in takes time. So I have to go back with a part, come back, and then it's not right, and then this, and then change that. I just thought, the hell with it. Let me just buy it and make it myself. Then I can do whatever changes I want, and that's it. So having said that, let's start with a short piece of aluminium, and this is where your veneer and ChatGPT is going to come into play. So everything is using different speeds. They have different ideal speeds. So when I measure this piece of aluminium, it is a 19 millimeter. I don't have to get super accurate for this bit. I just need to get a good idea, ballpark figure of what's going on here. So I've got a 19 mil piece of aluminium that I want to turn, and it's a bit sketchy and it looks a bit dodged, so we're going to measure it up. So then I get onto ChatGPT, and I'm going to say, what is the correct RPM for turning a 19 millimeter diameter aluminium in a mini lathe. It's important to say mini lathe because it does help you out when your RPMs are going out of spec. Because now it says to me to calculate the correct or blah, blah, blah. They're going to give me all sorts of calculations, which you can work out, you can learn. But they really are just going to say, with a carbide tip, 3,500 to 4,500 RPM. With a high-speed steel tool, use a lower speed around 1,000 to 2,000. So it says notes for a mini lathe. Most mini lathes can't reach 4,000 plus. This one only does 2,500. That's still acceptable. Just take lighter cut and use cutting fluid. So lighter cuts, we're going to get over. We've got cutting fluid. Watch for chatter or overheating if this happens. Reduce feed rate, which is this, or RPM. Now note that it does say with a carbide tip or with a high-speed steel tool. So basically, a lot of these things are limited by the RPMs on this, and often you may find that a high-speed steel, which is, you see, this tip is made out of carbide, and then you get a high-speed steel tip, which is basically looks like that. It's made out of high-speed steel, and you grind your own tip into it. Those can do lower RPMs, and it is my suggestion that you do get a few of those in case you run into situations like this where your machine just cannot do the RPMs. It's not the machine's fault. It's a mini lathe. It's not supposed to, it's not industrial. It's small home use. So you want to get that sort of centered in there, and then get your tooling out the way like that. So we're in. I've not over tightened it. I've just got it in there. And this is where I'll make sure I'm in the forward direction. This little micrometer comes into play. And it can become pretty handy. Because what you want to do with it, get it set nicely. I think there's something underneath there. Get it firmly on the workpiece. Right, so it's kind of firmly on the workpiece there. And when you turn it, that gauge, can you see it moving? That shows you how out it is in that direction. So what you sort of want to do, so I think that's its lowest point. You just turn the outside, loosen it, get the outside onto the needle. They very finicky. I mean, look how tight in there, and it changed. So you sort of want it on there. Now I'm just going to turn this very slowly, and not forgetting to lift that. There you see the light came on. So if your light's not coming on, you try to turn it on with that off. And you see how far out it is, eh? So that's pretty out there. It's not the end of the world, because that's what we got a lathe for. Okay, so I've kept that out the way. Now what you want to do is, no, that looks all right. Let me see if I can zoom into this, because that will help. Sorry about the camera moving the whole time. There we go. Now we are up to, I'm going to bring it in to just close on where it is. I'm going to disengage the auto feed. And I'm going to start spinning, and then I'm slowly going to move these forward and backwards until I get that tool to start cutting along here. So here goes. That's up. We're in forward. We're in a gear. Don't know what gear. I can engage it. Yep. I like that direction. Yep. Now I'm going to slowly move it in. Okay, so now it's starting to cut. And I'm going to, before I do this, I think I'm going to take the camera off so you can get a better view, because I can't really get on top there with it. And I'm going to show you what I'm doing. I'm just turning it up until it starts to make contact with it. So there you can see it's starting to make contact. And then we're going to do a run. I've made sure that my auto feed is in the correct direction. My RPMs must be on 2,500. So that's high. I made sure I'm in high gear here. And that's lift up. I'm in forward. And the only thing I haven't done yet is get some oil. So we're going to start with that. Okay, now when I engage it, it's slowly starting to cut. So now, because I don't want to do the whole thing, I'm just going to make a few short passes. So you watch how it's turning. We're on 2,500. You got to watch for this here at the end, that it doesn't run into it. And disengage. There are still some points. So if you look at that, it's a little bit rough, again, because of the RPMs. We would have had a better finish, but also it's a bit rougher because I went over it. So if I go in, and I'm just going to really start to knock this out a little bit closer in. This might put a lot of stress on. So it's always good to have the motor running before, so when it's up to speed, before we whack on the auto feed. Let's do it one more pass. Auto feed on. Now I've disturbed that process because what I want to show you here, you see there is still some fine lines there. Okay, it's very fine. They would have gone with high-speed tooling at high-speed steel instead of tungsten carbide. Don't have high-speed steel bits, so I got to make do with what I got to make do. And on high-speed steel on 2500, because there you see it, and that is rougher because remember I ran it manually across with this lever, and that caused that. So your auto feeder is super important to get a proper smooth finish. We're going to get to the deflection in a bit, but what I want to just do is get on the micrometer. So we'll pop that on, I think over here where we've worked, eh? So I'm going to zero it. Every time before you switch the machine on. These things are finicky. That's good enough for me. Make sure auto feed disengaged, and let's get it on slow, because you're going to be focusing on this and this thing's just going to start coming, bringing a cutting tool into there. You don't want that. So we're just going to slowly run it. And look at that difference in variation. There's a massive difference in variation between what it was doing and what it is doing now. And that was a really sketchy piece of aluminium, and that is now starting to become something. So this is some basics. I do need to clean the bottom of this before, so I'm just going to move that here to remind myself. And that's how I came from a exactly piece like that to making a nice little. Don't know what it is. This is the first thing I've ever made on a lice, on a vice, on a lice, on a lathe. First thing ever. And yeah, it's like a barbell for cats, or I don't know, but I like it. I made something. It's a good start. So there you have that. Your tooling, your having a vacuum cleaner on hand is great. Now, just one more thing that I want to show you. I think that pretty much covers everything. You want, as you just want to have really thin passes at it. Take your time. That's where the patience comes in. So we're going to go over fitting something onto the tailstock, because there's another mistake I made. Just I like learning the hard way here. If you've got your tailstock, it's got two levers, one at the back here, so you push it down, that's going to move it forward, that's going to move it backwards. When you want to fit something, so let's do that. You want to go back, and you're going to see it isn't going to go all the way in. So what you have to do is extend that. Because you'll see the bolt that controls this is protruding out inside there. Now it's going to fit, right? So what you want is you want it on there, and you just give it a good whack in, and it will wedge in. Don't learn the hard way like I did. What you do is you lock it first, like that, and then you give it a good wedge and it's in. If you don't lock it first, that bit's going to go flying off. And I had to look for it down below there. It wasn't fun. I was like, oh, bugger. Another lesson learned. So make sure it's nicely locked. Then you can retract it a little. And this is why you cut off that tail piece. So this will now... So you just want to retract it until you sort of start very, very... You don't even want to get to the point where you feel a little bit of friction. That's good enough. Move it up to your workpiece and clamp it back. And then use this to move into your workpiece and come out again. You want to have it extended as much as possible. This extended as much as possible, so allowing for your depth of drilling. Because to remove this, you're not just going to pull it out. You wind it all the way down, and the operating bolt here actually pushes it out. Pushes up against there and knocks it out. Easiest way to get that out, you're not going to struggle and damage your bits on something, or damage something here, or damage yourself. I think you'd rather damage yourself before you damage your bits or anything. So that's why, make sure it's locked, make sure it's out of it, give it a wedge in, and then wind it up, bring it close to the workpiece, and then wind it in. Because you don't want to, while your workpiece, retract it, and that thing pops out while there's something working. These are for stabilizing something a bit bigger than like that. So you can see there's a flat in there, so that's going to go in the chuck that way. And one of these, probably the heavy duty one, I'll first take the drill, center drill piece, and I'll drill a slight hole in there. That will then go in that hole and help stabilize it, because that's a hell of a weight to be swinging around. So I think that kind of wraps it up. Very little you cannot do. These are for center boring. So these also go on the chuck like that. And then you use that to bring it in. I actually don't know. I think you're working on the distance out from there or something. I don't really know how one would actually literally move this around. Maybe it goes, yeah, it goes in here. I would think it, can go in there, but it's round. So I don't know. That'll clamp it. Oh, it's round because you want to do it. Anyway, that's another day's worries. What we're going to do is worry about this for today. As you can see, there's a lot of tools. There's a lot of things you can do. There's a lot of things you can get. When you're finished, make sure you are properly shut down and obviously clean up a bit. And that's it. The Afric BL180 mini steel lathe. What more can I say? What more do you need? As a beginner, what more do you need? I don't know. As you can see, we are up and running very quickly. It's not very difficult. We've already turned our first piece. There it did. I'm not saying it doesn't get difficult. It gets very difficult. And it gets very tricky. And there is an art to it. But just to get up and turning, that's it. You're there. No funny surprises. I think it pretty much covers everything. So again, guys, if you enjoyed this video and if it has helped you, please do like and subscribe. Thank you very much.